In this video, we'll be looking at vector addition and subtraction. So to add or subtract two vectors, you perform the operation component by component. This means you only combine the x values, y with y, and z with z. So let me show you what I'm talking about. Let's start with the addition part of it. So what I mean here, let's say we have a vector. These are our components. Okay. We have this as our components, and let's say we have a second vector and we have this as the component of the second vector. Okay, my previous videos I explained this whole thing, so I'm just only going to talk about addition and subtraction today. Yeah, so if we're asked to sum up these two vectors, let's say we're going to have the answer of C. We're summing up these two vectors here. So what we're supposed to do here is to perform the operation component by component. What I mean by component by component is that these two are same component. These are same components. These are same components. So sum them up component by component. So for our first component here, we have ax plus bx. Let's factor out our unit vector outside. This is called the unit vector, plus we have our second component as ay plus by. Let's factor out our unit vector, and we have plus az plus bz, factoring out the unit vector. So this is what I mean basically. We sum up, we do the addition of vector component by component. This is a component, this is a component, and this is a component. Now the subtraction is also same thing as the addition. It's just only the sign that is changing. So like earlier roots. So to sum up these two vectors right here, we just have to do same thing. I'm sorry, to subtract these two vectors, we just have to do same thing as we earlier did in summing up two vectors. So we do it component by component. That is, we have our ax plus minus bx, since we're subtracting bx. Let's not forget our unit vectors here. We'll just factor them outside. Then we have our ay minus by. Let's not forget our unit vector outside here. And then plus az minus bz. Let's not forget our unit vector right here. So this shows basically the sum, the addition and subtraction of vectors. Let's look at an example. Let's say we have, if vector A equal to 10 unit vector, the unit vector is just showing the direction of the vector. I explained that in my previous video. And we have our second vector b, which is 2ax plus y, and we're asked to find, let's say, we're asked to find the components of E along the unit vector, that is along the path, and we're asked to find the magnitude of, let's say, 3 of the vector minus second vector. And third question, let's say we're asked to find a unit vector along this vector. Alright, so from the question here, the first question says component of the first vector along the unit vector. So as we can see here, we can see that the component, or should I say the value attached to this unit vector is -4. So therefore the component of this vector along the unit vector is therefore -4. So our first answer is -4. Our second question now is magnitude of 3 vector E minus vector B. So we have our vector E as 10 unit vector minus 4 unit vector plus 6 unit vector, and now they said 3a. So 3a means we should multiply this whole equation by 3 so that we can have 3a here. So if we should multiply the whole equation here by 3, we should have 3a vector equal to 3 times 10, we have 30. Let's not forget our unit vector here, minus 3 times 4, we have 12 here, plus 3 times 6, we have 18. Let's not forget to write our unit vector right here. So we have this value. I will now ask to subtract this value from -b. So this is the value of our -b here. So if we're subtracting, we should have this minus b. So if we're subtracting, we should have 30 minus, what's the first thing along this axis? We have 2. Alright, we're having negative sign here because this is minus b. So minus b here means that the whole sign of this equation is changing. So this would be something like -2, -1 here. Right, so we now continue from where we stopped. So we have plus -12, -1, plus okay, since we don't have along this part only 4 here, so it's just like saying 18 minus 0, which is still 18. So let's continue our calculation up here. So after subtracting from what we have in our previous what we did previously just now. We have our answers 28, its unit vector, minus 13, its unit vector, plus 18 and its unit vector. But this is not what we're asked to find. We're asked to find its magnitude as stated here. And to find the magnitude of this vector, we use the Pythagorean theory, which is the square root of ax square minus b minus ay square, sorry, it should be plus here, plus az square. So in this vector here, we have our ax as 26 square plus should be minus, sorry, minus 13 square plus 18 square. So if you should do your math here, we should have the square root of 1277. So therefore our magnitude here of the vector is equal to the square root of 1277 is 35 plus 0.74. So now for the third question here, we are asked to find a unit vector along the first vector plus 2 times the second vector. So we have our second vector here as b equal to 2 unit vector plus plus 1 unit vector, but they said 2 here, so we should multiply this this vector by 2. So when we do that, we should have 4 unit vector plus 2 unit vector. So we're now asked to sum this up by should sum this up with our first unit vector, that is the a with the arrow over it. So to sum this up now, we should have, so 10 plus 4, we have 14 minus negative 4 plus positive 2, which is negative 2. Let's not forget to write our unit vector here. Plus, since there's nothing here, we're assuming to be 0. So we just write this, because 6 plus 0 is still 6. So this is the sum of it, but we're asked to find the unit vector. So as you can see here, this is our vector, but to find the unit vector we have to know our magnitude. So let's find the magnitude. We use the Pythagorean theory to find the magnitude. Let's not forget the formula again. To find the magnitude A, we can write it as ax squared plus a squared y plus a squared z. This is the formula. So we have our first magnitude here as 14. We have our first magnitude here as 14. So write 14 squared. We have negative 2 here. So plus negative 2 squared plus 6 squared. If you should work this, we should have the square root of 236, which is decimal. We can also write it as 15.36. So now to get our final answer, which is the unit vector, the formula of the unit vector is the vector divided by its magnitude. So unit vector, the unit vector, so this is the vector divided by its magnitude. This is a sign for magnitude. Yeah. So we have our vector, which is this, as 14. Let's not forget to try out unit vector plus, let me just wipe this so we can have space to write. I said it's equal to 15.36. Sorry, it should be negative here. Negative 2. Let's not forget our unit vector plus 6 and unit vector, all divided by, we got 15.36. So this is 15.36. So to simplify our work now, we can write this as 14 divided by 15.36 ax minus 2 all over 15.36. I'm just distributing the denominator, plus 6 all over 15.36 az. So this is our final answer of finding the unit vector, which is this.